Hi guys, and welcome back. So this is day 9. It is solving systems of equations by substitution, and it's our first day of solving systems of equations. And so we're starting with substitution, which is a little bit different, but you'll see why in the end. But the objectives of this portion is to be able to use algebraic strategies to solve systems of equations. So you're going to use substitution and some algebra to solve them. And algebra is just a fancy way of saying you're going to do some math, you're going to use some inverse operations, and you're going to solve for each variable individually. So the first thing we might ask is, what is a system of equations? And so we talked about in class, it's one or more equations that you're going to deal with kind of all together. And they're always going to be dealing with the same values. They're going to be graphed on the same graph. And the solution is going to be wherever they intersect. And that's the key piece there. It's where they're intersecting. And so this week, we're going to look at how we can do that by using the solving strategies that we've used in other solvings of equations. And then next week, we'll look at how we can do it graphically. So there are 3 types of systems of equations. We have a consistent system, a dependent system, and an inconsistent system. The consistent, which is also sometimes called independent, is just 2 lines that intersect in any way. And you'll always have one solution there. And as we said, it's going to be where they intersect. So it's just going to be 2 intersecting lines. They could be perpendicular or not. They just cross each other somewhere. The next type is a dependent system. And this is the same line. So it's dependent because they depend on each other to be the same. And in this case, the lines are the same, so they intersect each other everywhere. So if you were to graph those 2, you'd graph the first one, and then the second one would be graphed right on top. So they're gonna intersect everywhere, which makes infinitely many solutions because those 2 lines are sitting on top of each other. The last type of system is an inconsistent system. And this is a set of parallel lines. And so there will be no solutions for these because they never intersect. We know that by definition, parallel lines are lines that never intersect. So as you see in my 2 green lines at the bottom there, they're parallel, they're not going to cross each other, so there would be no solutions. Here are the steps. I'll let you kind of read through those on your own. The key is that we want to have one of our equations solved for one of our variables. And then we want to do some substituting, solving, and then substituting some more to find a final answer, which we should remember will always be a coordinate point. So it'll always be listed as x comma y, no matter which one we solve for first. So in class, we worked on examples 1 through 4. I want to go and start out with number 5. So when we look at number 5, we see that the top equation is solved for y. So we can take that 6x minus 11 and we can replace y with that expression. So we get negative 2x minus 3 times 6x minus 11 equal to negative 7. At this step, we should have one variable in our equation. And that variable is the x, because that's the one we didn't have anything solved for. Once you've done that, then you can distribute that negative 3 in, making sure to watch the sign in front of it, and remembering that distributing is just a fancy word for multiplying. So we have negative 2x minus 18x plus 33 is equal to negative 7. Once you've distributed, we have a bunch of things on one side and only one thing on the other. So we want to simplify this by combining some like terms. So negative 2x and negative 18x make negative 20x plus 33 equal to negative 7. Then we can move the 33 to get that x term by itself. So this is just like solving individual equations, like one variable equations, like we did back in Unit 4. And then our last step will be to divide by negative 20, which gives us that x is equal to 2. Once you get your value for x, we can take that and we can substitute it back in for x in our top equation. You really could substitute it into either one of these equations to be able to solve for x to get or solve for y to get the x value, but we always want to work smarter, not harder. So the top equation already is solved for y, so it'll require less work to plug in there. So we'll do 6 times 2 minus 11. 6 times 2 is 12, minus 11 gives us a y equals 1. Remember that we found a coordinate point, so you're going to write your final answer as a coordinate point. So it'd be 2, 1. Again, the x is first because x is first in a coordinate point, not because we solved for it first. Now let's take a look at number 7. Once again, we see that the bottom equation now is solved for y. So we are going to take our x minus 1 and plug it into the first equation for y. So we get 2x minus 3 times x minus 1 equal to negative 1. Again, you can just make sure that you have one variable left in that equation, which we do. There's just x's. So we can go ahead and distribute our negative 3 into the parentheses. So that's 2x minus 3x plus 3 equal to negative 1. Combining like terms, we get that negative 1x plus 3 is equal to negative 1. Minus 3 from both sides, so we get negative 1x is equal to negative 4. And then lastly, we divide by negative 1 to see that x is equal to positive 4. Again, the last step is to find y because we had two variables to begin with, so we need to find the value of both. And this time we're going to take the 4 and plug it into the bottom equation for x, since that is the equation solved for y. So we're going to have y is equal to 4 minus 1, which is 3. So our final answer is 4, 3. Now let's take a quick look at number 4. This one is different because now we have our bottom equation solved for x. So we're still going to plug in, but now we're going to plug in negative y minus 1 for x in the top equation. So it's going to be 5 times negative y minus 1 plus y equal to negative 17. Then we're going to do our distributing just like before, remembering to check to make sure that at this point we have one variable. Once you've distributed, remember to combine your like terms. So negative 5y plus y gives us negative 4y minus 5 equal to negative 17. Then add 5 to both sides to get that negative 4y is equal to negative 12. Lastly, divide by negative 4 to both sides, so you get y is equal to positive 3. Just like before, we still want to make sure that we have a value for both variables. So we're going to take 3, but now we're going to plug it in for y because that's what we solved for. It's important to make sure that you keep up with your variables and keep bringing down the same variable and not switch midway through. Also, to write neat enough that you know if it's an x or a y. So we're going to say that we have x equals negative 3 minus 1. Remember that negative in front is kind of like negative 1. So you have a negative 1 times 3, which is negative 3 minus 1, which is negative 4. So our final answer is going to be negative 4, 3. Even though I solved for 3 first, that was my y value. So it still needs to be second in my answer because that's where the y coordinate goes. If you have any other questions, please make sure that you ask me in class or set up a time to work with me. I hope this was helpful, and I will see you in class. Ta-ta!